Assalamualaikum and good afternoon. My name is Muhammad Haikal Hadi, and today my group will be representing Engineering Mathematics 2, which is DBM20023. The topic will be application of differentiation, and my members are Muhammad Shakir Aiman bin Muhammad Jumat, Tawashilan Anak Lelaki Jivan Nantam, and Mariam Nabila binti Ritzuldin. So, what is differentiation? Differentiation is about finding rates of change of one quality compared to another. So, in differentiation, there is dy dx and also fx, which is function. dy dx represent rate of change, while function fx represents physical quantities. So, when the rate of change is not constant, we need to use differentiation method to calculate the calculations. And also, there are three types of application of differentiation that we can use, which is finding stationary points, rates of change, and also total differentiation.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Mariam Nabila binti Ritzuldin. My metric number is 08DKM2F2020. So I will explain about the application of differentiation, stationary point. The first one, we can find stationary points by using differentiation by the graph or sketch the graph. The second one is there are three types of stationary points, which is maximum points, minimum point, and point of inflection. And the last one is the stationary points will only occur when dy per dx equal to 0. This one is ways to determine the type of point. To determine the stationary points is either a maximum, a minimum, or a point of inflections. We must apply second order derivative. The first is if t power of 2y per dx power of 2 greater than 0, it is a minimum point. If t power of 2y per dx power of 2 less than 0, it is a maximum point. If t power of 2y per dx power of 2 equal to 0, it is a point of inflections. Application of partial differentiations to maximum and minimum problems. Dy per dx equal to 0 is the sufficient condition for maximum or minimum of fx. Minimum is concave, which is for d power of 2y per dx greater than 0, and maximum is convex for d power of 2y per dx power of 2 less than 0, and inflections graph for d power of 2y per dx power of 2 equal to 0. So to minimize z equal to f x y, z per x equal to 0 and z per y equal to 0.
Good afternoon, everyone. My name is Tawashilan. I'm from class DKM2A. My metric number is 08DKM20F2004. Today, I would like to share about application of differentiation. Here's the example question. So, given a curve y equal to 5 plus 4x minus x squared, so they ask find the stationary point and determine whether it is a maximum or a minimum point. So you first write the equation, which is the curve equation, y equal to 5 plus 4x minus x squared. So you differentiate the curve equation, you get 4 minus 2x. At stationary point, the gradient always equals to 0. So dy or dx equal to 0. you already get your dy over dx, which is 4 minus 2x equal to 0. So 2x equal to 4, x equal to 2. So you already get the equation of x. So sub x equal to 2 into equation y, which is the curve equation. So y equal to 5 plus 4 times 2 minus 2 squared equal to 9. Therefore, the stationary point is coordinate is 2, 9. So when you differentiate the second time from this, you get -2. So when you get -2, it's lesser than 0. So this coordinate, the stationary point coordinate 2, 9 is a maximum point. Okay, next we move on to example questions and solution for parametric equation. So this question, it is given y equal to 4 cos t and x equal to 5 sin t. So they're asking find dy over dx, which is gradient. So first step, y equal to 4 cos t. Differentiate this equation in terms of t, you get -4 sin t. Next step, x equal to 5 sin t. So you differentiate in terms of t from the x equation, you get 4 cos t. So when you do it upside down, like dt over dx equal to 1 over 5 cos t. So the final step, to find gradient. So dy over dx equal to dy over dt times dt over dx. So we cut dt dt, you get dy over dx. So -4 sin t times 1 over 4 cos t. Don't forget to put the bracket here. So -4 sin t over 5 cos t. Your final answer is -4 over 5 tan t. That's all.
Okay, my name is Muhammad Syakir bin Muhammad Jumat from DKM2A. So this one for presentation for mathematics. So application of differentiation graph. So to sketch a graph, we need to find the point where curve meet x-axis and y-axis. When the point of the curve meet at x-axis, y equal to 0. When the point of the curve meet at the y-axis, the value of x is 0. Okay, for conclusion, in our daily life, we can apply the technique in solving application of differentiation. Differentiation is very useful to us. Differentiation helps us to think out the box to solve differentiation equation. Okay, sekian, terima kasih. Thank you.